Welcome to another episode of my review series for civil engineering topics focusing on fluid mechanics problems. For this situation, a dam 4 meters wide at the top, 16 meters wide at the bottom, and 24 meters high has water 18 meters deep on its vertical side. Assume a coefficient of friction of 0.8 and neglect uplift in answering the following questions. What is the factor of safety against sliding? What is the factor of safety against overturning? And find the soil pressure at the heel. For this one, when it comes to encountering this topic sa board exams, yung iba minsan nagtataka kung bakit to kasama sa subject na PSAD. Usually kasi, pag natatakal to sa mga college lectures, lagi itong included sa module ng fluid mechanics or ng hydraulics. Pero kung papansinin nyo kasi, pag sinagutan natin to, more on analysis ng forces na nag-a-act sa structural dam yung ina-approach natin. At the same time, gaya nga ng isa sa mga hinahanap sa problem na to, involved rin yung ibang PSAT topics like yung sa paghahanap ng pressure. So, technically speaking, valid pa rin naman siya na makonsider for PSAT test. Para masagutan natin yung mga questions, alamin muna natin yung mga formulas na need gamitin para sa mga factors of safety. Starting with our factor of safety against sliding, the formula we have to use in order to solve for that is mu times resultant force along vertical over resultant force along horizontal. So kung papansinin nyo, pang structural analysis talaga yung approach niya. Pero for this one, nasa basic part pa lang tayo ng problem. Kasi aside from summation of forces lang need natin gawin, given pa tayo ng condition na neglected yung uplift force. So di na muna natin kailangan isipin yung mga seepage na nagaganap sa soil or whatsoever. Moving on, coefficient of friction natin is already given, which is 0.8. Tapos for our Ry naman, yung makikita lang naman natin na vertical force na nag-act sa figure is just the weight of the dam itself. Therefore, let's just solve for the weight by using the formula gamma over volume. And since di tayo given ng value ng unit weight, gamit na lang tayo ng standard value ng concrete, which is 23.5 kilonewtons per cubic meter. Para sa volume naman, kunin lang natin area ng figure tapos multiply natin sa width ng dam. Pero since wala din tayong present na value ng dam width, assume muna tayo ng value. So let's say 1 meter muna yung haba ng dam para convenient. Solving for our weight, or the value of our vertical resultant force, 23.5 times volume of 240 cubic meters per 1 meter width. We will get a value of 5,640 kilonewtons. So kung mapapansin nyo, yung unit na ginawa ko dito is kilonewton per meter. And the reason for that is, kailangan natin i-keep in mind na yung resultant force na yan is considering the assumed length of 1 meter width. So let's say magkaroon tayo ng given width na 5 meters. Need lang natin siya i-multiply by 5 para makuha yung actual weight ng dam. So dapat keep in mind yan while moving forward sa pag-solve. For the resultant force naman along the horizontal direction, the only force present in this figure is yung due to water pressure. And recalling our formula for hydrostatic force, this is just equal to unit weight times centroidal height from the top times area perpendicular to the force applied. Since water lang naman ang fluid na involved sa system natin, gamit lang tayo ng standard unit weight na 9.81 kilonewtons per cubic meter. For the centroidal height naman, yung water level natin is at a depth of 18 meters. Therefore, ang centroidal height natin from the top surface is 18 divided by 2. And assuming na 1 meter width yung haba ng dam natin, yung area ng application ng hydrostatic force is just 18 by 1. Now, plugging in these values sa hydrostatic force equation natin, we'll get a value of 1,589.22 kilonewtons per meter. Again, naka-per meter ang sagot natin dahil yun yung assumed width natin ng dam. Since completed na yung need nating values to solve for our factor of safety against sliding, plug in na lang din natin to sa equation natin and we'll get a value of 2.839. On to the next one. Our factor of safety against overturning has the equation of Rm over Om, or righting moment over overturning moment. Yung righting moment natin, these are the moments about the toe from our present vertical forces. Tapos for overturning naman, ito yung mga moments from horizontal forces. So just to elaborate quickly, para lang rin di kayo malito sa label ng dalawa, explain lang natin yung concepts ng dalawang moment. Let's say ang present force muna natin sa figure is yung hydrostatic force. Neglect muna natin yung presence ng weight ng dam. So if walang weight si dam, tapos in-apply natin tong push ng horizontal force sa kanya, may tendency yung figure natin na mag-tip over about the toe, or yung tinatawag nga natin na overturning. So para maiwasan yun, necessary na meron tayong enough na bigat para sa dam para ma-maintain yung upright na position. Doon naman papasok yung role ng vertical forces natin na nagpo-produce ng righting moment. So kaya rin tayo may kino-consider na factor of safety for overturning is because need natin malaman if sufficient yung righting moment natin or tama yung pagkaka-apply ng vertical forces natin para maiwasan yung pag-tip over ng dam. So para di kayo malito sa kung alin yung forces na may righting moment or overturning moment, tandaan nyo lang yung concept na to. Going back, solving for our righting moment, multiply lang natin yung weight times yung distance ng resultant force niya mula sa toe. Pero since yung figure natin is a trapezoid, mas convenient kung i-analyze muna natin to into separate basic shapes as shown in the revised figure. Solving for the moment caused by our weight 1 muna, kunin muna natin yung value ng weight. So unit weight of 23.5 times volume. And to get the volume, area lang ng 4 times yung height ng dam natin which is 24, tapos times din natin sa assumed na dam width na 1 meter. That would give us the magnitude for our weight 1. Para naman sa distance niya mula sa toe, ang position lang ng 4 sa rectangular area is in the middle. So yung length na 4, divide lang natin sa 2, so 2 meters lang yung position niya mula sa heel. Getting its distance from the toe, minus lang natin yung 2 sa total bottom length na 16 meters. Para naman sa moment due to W2 or weight 2, 23.5 times volume by area of triangle na 1/2 times base of 12, since 16 minus 14 na length ng triangle, tapos times height of 24 times assumed width na 1 meter. That would give us the value of W2. Para naman sa distance niya mula sa toe, since right triangle yung shape tapos yung bottom angle natin is nasa right side, ang magiging centroid distance ng figure natin would be positioned 2/3 of the base mula sa toe ng dam natin. Now solving for our righting moment, we will get 58,656 kilonewton meters. Next naman, para sa overturning moment, ang usual distance lang naman ng hydrostatic force na applied sa isang rectangular area is just 1/3 of the height from the base. So multiplying 1,589.22 kilonewtons by 1/3 of the water depth na 18 meters, we will get 9,535.32 kilonewton meters. With that, pwede na natin makuha yung factor of safety against overturning, which is just 58,656 divided by 9,535.32 equal to a value of 6.141. This time, let's solve the pressure at the heel naman. If we are to analyze the equivalent force of our weight at the base of our structure, we can say that our dam base is experiencing a distributed load. And dun sa area na applied yung distributed load na yun, ang hinahanap natin is yung magnitude ng pressure sa hillside ng area natin. And take note, 1 meter width pa rin yung assumed width natin sa area na to. But before we proceed sa paghanap ng magnitude ng pressure, need muna natin malaman kung paano yung pressure distribution ng dam sa base area natin. And we actually have two conditions that we need to consider first para malaman natin paano solution ang need natin gawin. This involves the positioning of the resultant force from the centroid of our area, or as we call it, yung eccentricity ng force sa area. So looking at our given figures, ang pressure distribution natin is in the shape of a trapezoidal prism if the eccentricity of our force is less than 1/6 of the length of the dam base. If it is greater than or equal naman, triangular prism naman yung distribution ng pressure sa area ng base natin. And actually, basic lang naman yung logic dito. Kasi kung maaalala nyo, ang centroid ng triangular distributed load is 1/3 from its high end. And technically, yung distance nun from the center of the length is half ng 1/3, which is 1/6. So kung mas malapit pa yung distance ng force natin towards the center, ibig sabihin may additional uniform load na along sa length, thus forming the trapezoidal distribution load natin. Going back, kunin muna natin yung eccentricity ng force natin. Para makuha yun, pwede tayo gumamit ng Varignon's theorem wherein yung moment ng resultant force natin is equal to the total moment applied by our individual forces. And fortunate for us, madali na natin yun makukuha kasi nag-solve na tayo kanina ng writing at overturning moment. And given na sa to ang pagkuha natin ng moment, using counterclockwise positive reference, minus lang natin si OM kay RM para makuha yung total moment value natin. Proceeding with the equation, denote natin yung distance ng resultant force ito as letter X. Solving for its value, we will have 8.709 meters from the point of the toe. Now, since ang gusto natin makuha talaga is the distance from the center, minus lang natin yung value na 8, which is yung half ng length kung saan nakaposition yung centroid ng area natin. Doing that, we will get an eccentricity measure of 0.709 meters. So this actually suffices the condition that our eccentricity value is less than 1/6 of our length, which is 2.667. Therefore, this figure na ang susundan natin sa pagdetermine ng pressure value. So given na ito yung susundan nating figure, pwede natin to gamitan ng concept ng force equilibrium para ma-determine yung magnitude ng unknown pressures. Pero kung papansinin nyo, dahil trapezoidal figure yung loading natin, technically dalawa yung unknown pressures na need natin ma-determine. In order to do that, since two unknowns tayo, gamit lang tayo ng two equations na pwede natin isolve simultaneously. For our first equation, pwede tayo gumamit ng Varignon's theorem wherein take natin yung moment about sa toe ng dam. So yung resultant force along vertical, which is 5,640 kilonewtons, times yung distance niya from the toe, which is 8.709, is equal to the sum of the moment of our forces. So since trapezoidal law to, pwede natin to hatiin in this matter. Then ang moment is just 1/2 times base times height times centroidal distance. So same base, different height values, and since parehong triangle load ang hati natin, magkaiba lang ng way ng pagkuha ng centroidal distance kasi yung height value ng isa is nasa left, tas yung isa naman is nasa right. Para sa triangle na may heel pressure height, yung position ng force niya is 2/3 ng 16, while yung triangle naman na may toe pressure height, 1/3 ng 16 naman yung distance ng force. Simplifying this, we will get an equation of 49,120.68 equal to 42.667 times pressure at toe plus 85.333 times pressure at heel. For our second equation naman natin, pwede natin gamitin yung summation of forces lang. So for this one, total force of 5,640 is equal to the magnitude of our trapezoidal pressure, which we can get by having the average of heel pressure and toe pressure times yung length distance na 16. Further simplifying, this will give us an equation of 705 equal to the sum of the toe and heel pressure values. Since meron na tayong dalawang equation, solve simultaneously na lang natin to sa ating scientific calculators and we'll get a value of toe pressure equal to 258.734 kilopascals. And yung heel pressure na hinahanap natin is equal to a value of 446.266 kilopascals. So kung papansinin nyo, medyo time-consuming tong ganitong method kasi need pa muna mag-derive ng formulas tapos solve simultaneously. The good news though is meron pa tayong isang alternative solution na kung saan may need lang tayong sundan na equation. And that is the equation for combined axial and bending stress, which is equal to the sum of the resultant force over area and the moment of that force about the centroid times the distance of the centroid from the analyzed position over the moment of inertia of the base area. As for the sign conventions, para sa axial stress, positive yung gagamitin if under tension, tas negative naman if under compression. So for this figure, dahil downward force yung applied, negative sign convention gagamitin natin. For the bending stress naman, positive tension at negative compression pa rin naman ang reference. Pero ang force na i-consider natin is yung bending moment about the centroid of the area. And based sa figure natin, kung yung force times distance natin is moving counterclockwise toward the side of the heel, then yung moment natin is actually causing that side of our area to compress. Therefore, negative sign convention din gagamitin natin to solve for that. Tapos, if curious naman kayo about the toe pressure, yung side naman ng toe na area is actually bound to slight tension kasi bend away yung motion. So, yung pressure sa side na yun is actually positive. Bigyan ko to ng in-depth discussion soon pag nagka-time na ako para gumawa ng lecture video siguro. Pero anyways, mag-plug na tayo ng values sa pressure formula natin. So, ang P-value natin is yung force 5,640 kilonewtons. Area ng base is 16 by 1 meter. Then, yung moment na force natin about the centroid is 5,640 times distance na 0.709. Yung C-value, which is the distance of the centroid from the analyzed position of pressure, is just equal to half of 16, which is 8 meters. Then, yung moment of inertia natin is base times height cubed over 12. So, base is 1 meter, then H value natin is 16. This will lead us to a pressure value of negative 446.266 kilopascals. Therefore, since kapareho niya lang yung nakuha nating answer kanina sa solution 1, we are now guaranteed na applicable alternative solution yung ginawa natin. Thus, this situation is finally solved.